What if I told you that there's a drug that's been sitting on pharmacy shelves for decades, originally made to prevent organ rejection, but it might just be the key to treating post-viral conditions like ME/CFS and long COVID? Today, we're diving into rapamycin, a medication that targets every major problem we see in post-viral conditions. But before we get too excited, there's something critical you need to know about the current research. I'm Courtney, and on this channel, I break down the complex challenges of post-viral illness using evidence-based approaches. No hype, no false promises, just the science. And a reminder, I live with this every day. I've been living with ME/CFS for over 26 years. Rapamycin has been FDA approved for over 30 years. Transplant patients take it every day to keep their bodies from rejecting the new organ. But researchers have discovered something fascinating. This drug might help reset the broken systems we see in post-viral conditions. A medication reset that targets not just one aspect of these conditions, but every aspect. To understand why rapamycin might work, we first need to understand what's going wrong in ME/CFS and long COVID. Think of your cells like tiny factories. In healthy people, these factories run smoothly. They make energy, they clean up waste, and they repair damage. But in post-viral conditions, something goes terribly wrong. There are four major systems that break down. First, energy production fails. Your cellular power plants, called mitochondria, can't make enough fuel. What they do make is very inefficient. It's like trying to run a car on the wrong type of fuel. Second, your immune system gets stuck in overdrive. Imagine your body's security guards working 24/7 without rest. Obviously, they become exhausted and they can't do their job properly. Third, brain inflammation. Special immune cells in your brain, called microglia, stay activated when they should calm down. This causes brain fog, sensitivity to light and sound, and worsens fatigue. The fourth thing is that cellular cleanup stops working properly. Your cells don't remove damaged parts anymore. It's like having a garbage truck that never comes, and the trash just piles up. So here's the key question. What if one drug could address all four problems? Rapamycin works by blocking something called mTOR. Think of it as your cell's main control switch. mTOR decides when your cells should grow and when they should repair themselves. And in ME/CFS and long COVID, this switch seems to be stuck in the wrong position. When rapamycin blocks mTOR, something very interesting happens. Your cells shift from growth mode into repair mode. They start cleaning up damaged parts again, mitochondria begin working better, inflammation starts to calm down. It's like hitting a reset button on your entire cellular factory. Now here's something really fascinating. You might already be doing things that work similarly to rapamycin. Fasting and ketogenic diets naturally lower mTOR activity too. This means some dietary approaches might influence the same pathways, but without the risks that come with taking a drug. You can learn more about how fasting and ketogenic diets affect mitochondrial health in another one of my videos linked above. So what does the actual research on rapamycin show? For the immune system, studies show that rapamycin can reverse T cell exhaustion, those worn out immune cells that I mentioned earlier. In some studies, it significantly reduced markers of immune exhaustion in patients. For brain inflammation, rapamycin can cross into the brain and calm down those overactive microglia cells. For energy production, the drug stimulates a process called mitophagy. Essentially, it helps cells throw out damaged mitochondria and replace them with healthy ones. A recent study tested rapamycin in ME/CFS patients, and 72% reported improvements in fatigue and post-exertional malaise. Sounds promising, right? But we need to pump the brakes here. This study hasn't yet been peer-reviewed. And now that means that independent scientists haven't checked the methods or confirmed the results. Peer review is crucial. It catches errors and helps us know if we can trust the findings. Now, more importantly, there was no placebo group in this study. Without comparing rapamycin to a fake treatment, we can't know how much improvement was due to the drug versus placebo effects or just natural symptom fluctuations. So the bottom line is, these results are encouraging, but they're preliminary. We need larger controlled studies to know if rapamycin really works. Let's also talk about the elephant in the room. Rapamycin isn't a harmless drug. Short-term side effects are pretty common: mouth ulcers, skin rashes, and digestive problems. Some people in the ME/CFS study experienced these. There are also long-term risks that are more serious, including elevated cholesterol, slow wound healing, and higher risk of infection. For ME/CFS research, rapamycin is typically given in far smaller doses than what it's typically used for in transplant patients. It's given just once per week rather than daily. This significantly reduces side effects while still targeting mTOR. But remember, we don't yet know the safest or most effective dose for post-viral conditions. It could vary widely from patient to patient, especially the most sensitive among us. The main reason for this is because the drug stays in the body for a long time, 60 hours, so individual responses could vary widely. So basically, some patients may need to take it less frequently than weekly to avoid side effects or symptom worsening. Here's what makes rapamycin unique. It's the first treatment that targets all 4 major problems in post-viral illness simultaneously: metabolic reset, immune system repair, brain inflammation reduction, and mitochondrial renewal. No other single therapy addresses this many pathways at once. There's currently a Mount Sinai study in long COVID patients, which uses rapamycin with a placebo-controlled group. So these results will give us much better data about whether rapamycin truly helps in post-viral conditions. So where does this leave us? Rapamycin represents genuine scientific hope for ME/CFS and long COVID patients. The biological rationale is solid, and early results are super encouraging, but we're not there yet. The current evidence is preliminary, and the risks are real. If you're interested in rapamycin, the safest approach is through a clinical trial or working with a physician experienced in using mTOR targeting drugs. So, what do you think? Are you following any of the rapamycin research? Have you tried it? Or are you trying dietary approaches that might work through similar pathways? Let us know in the comments. And if this video helped you understand the science behind rapamycin, please hit that like button. It helps other people find evidence-based health information. Thanks so much for watching, and I'll see you in the next video.